We continue slogging through the kinematics of simple harmonic motion. This has been tough sledding, and it's going to be tough for 2 more videos, but we're doing the best we can. What we're going to deal with now is the phase shift. And I'm not going to read all of this to you, but we went through in previous videos that the displacement time function for a mass on a spring oscillating back and forth in simple harmonic motion is given by this equation right here. And what we're looking at in this video and the next one is this phi term right there at the end. What is that? That term has to do with where does the mass start on its back and forth path? Does it start at the equilibrium position? Does it start at the maximum x displacement, the minimum x displacement, somewhere in between? Where? And depending on where it starts, that's going to tell us what phi is. And what we're going to do in this video is we're going to be able to figure out what phi is based on a graph. Now, when we graph this function, we need to graph x position versus time, and 1 cycle corresponds to 2 pi radians. So this amount of time between right there and right there, that amount of time corresponds to 2 pi worth of a phase shift. And so here's what we do. You can read this if you wish. Feel free to stop the video if you want. But essentially what it boils down to is we start with what I call our little cosine cow, and we need to move her, and she always starts protected. You see how she's underneath the shelter here. And then we need to scoot her to the left or to the right so that she bumps into the origin of the graph that we're talking about. And if we end up scooting her to the left, then that's going to be minus something. Phi is going to be minus something. If we scoot her to the right, it's going to be positive something. Let's kind of show you how that works here. So let's take a look at this graph on the right here. And the cosine cow, we might give her a name, Bessie. She always starts, we want to mentally put her under the shelter right there. In other words, under that first maximum, that's where she starts. And then we need to either move her to the left or to the right so that she bumps into the actual starting point of the graph. So if we move her to the left, we move her that far. If you want, you could move her to the equivalent point on the right, which would be right here. You see how the slope right there is positive and the x value is 0. Similarly, at this point, the slope is positive and the x value is 0. So if we scoot Bessie to the left, we're going to get minus phi, or if we scoot her to the right, which would be that far, it's going to be plus phi. And it doesn't matter whether we choose the minus phi or the plus. They're equivalent. We just have to pick one of them. In this case, you can see from this arrow tip to this arrow tip, that's 2 pi of a cycle, right? And so from here to here is going to be half a pi, and this is going to be 1.5 pi. If we scoot her to the left, that's going to be minus pi over 2. Look at that right there. See that? Minus pi over 2. Similarly, at the bottom of the screen, if we scoot her to the right, we could say plus 3 pi over 2. That's in essence how this is done. So let's try a couple more examples to see if we can get this. Bessie always starts underneath the first maximum. So mentally, we're going to put her right there. Why don't we do these other two? Let's put Bessie in. We'll put her right there. And where's the first maximum? Right under the first maximum. We need to scoot Bessie either to the left, which is to this point right here, or we need to scoot her to the right, which is going to be, that's where x is the biggest negative value, so we need to scoot her there. Scoot her that way, or we scoot her that way. So what's phi? Well, between these 2 points, that's 2 pi. So that would be 1 pi in the negative direction or pi in the positive direction. When we write this equation, we would write x of t is equal to the amplitude of the motion, or if you want to call it x max, you can do that, cosine omega t, and then you can either go minus phi if you want, or if you want to put plus phi, that's okay too. Those are the same answer. How about for the next one? Mentally, we start Bessie underneath this protective cover, right there, right underneath the first positive maximum. So we're going to scoot Bessie either to the left, or where's the point that matches up? It's got an x value of 0 and a negative slope, so that's right there. So she only scoot whoop, 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 there, that far. How far to the left is that? Wouldn't that be 1.5 pi? Negative 3/2 pi. And this way would be, when we scoot her to the right, that's a positive change, positive pi over 2. When we write this equation, we would say the amplitude, they might give you that. They might tell you what the amplitude is. Omega t minus 3/2 pi. Or if you don't want to put minus 3/2 pi, you can put plus pi over 2. All right, one more. This one, we're going to have to slice the fraction a little bit thinner here, I think. Here, we start with Bessie underneath the first central maximum, the first positive maximum, and we would need to scoot her all the way over to there. And so what would that be? That wouldn't quite be 2 pi, wouldn't it? Does it give us a hint in the problem right here at the top of the screen? Make any phi an even multiple of 1/4 pi. All right, so it's not 3 pi over 2, because that would only take us to right there. It's 1/4 of a pi more. I think that's going to be negative 1/4 more than 3/4 is 7/4, isn't it? Or if we scoot her, she only needs to scoot to right there. All right, because that point right there and that point, that makes 2 pi. So that would be positive pi over 4. So when you're writing this equation, you're going to go either minus 7. I'll do the other one this time. There we go. Doesn't matter which one you do. Either one of those. Plus pi over 4 or minus 7 pi over 4.